Hello and welcome to the screencast on Chapter 22 that's managing our own waste. That is going to take a look at industrial solid waste. We're going to try to cover quite a bit in here, so buckle down and hold on and let's go. So industrial solid waste is defined as waste that is considered neither municipal solid waste nor hazardous waste under the Resource Conservation and Recovery Act. This waste from factories, mining activities, and agriculture and petroleum extraction, and more. Industrial facilities generate about 7.6 billion tons of waste according to the EPA, and 97% of that is in the form of wastewater. Roughly 230 million or so tons of solid waste are generated by about 60,000 facilities each year. An amount similar to that of the municipal solid waste, and it's generated at various points along the process from raw material extraction to manufacturing and sale and distribution. Oh, I have the wrong screen up. I'm so sorry. Didn't notice that. Here's that field that we were talking about in the last screencast. Okay, sorry, this is what you're supposed to have up. So when we take a look at the different methods of waste disposal, reduction and recycling are the two things that are very similar to municipal solid waste. Businesses that dispose of their own waste on site must design and manage their landfills in ways that meet the state, local, and tribal guidelines. There are businesses that pay to have their waste disposed at the municipal sites, while there are others that will generate and take care of their own. The federal government regulates municipal solid waste, and then the state or local governments regulate industrial waste. The regulation will vary greatly from place to place, but in most cases the state and local regulation of industrial solid waste is far less restrictive than the federal regulation is. Okay, we're not advancing forward. Okay, so let's take a look at this graphic. This is a flow chart that shows that waste generated at multiple stages in the life cycles of products, and each stage represents opportunities for efficiency improvements such as reduction and recycling. So here's our source, and we're extracting it, and then we're going to send some of that extraction off as waste. What we get is raw material, and that raw material will be refined, and in that refinement there will be some more that is going to be taken off as waste, industrial waste. Now we have crude material, and we can fabricate that crude material, meaning that we can do stuff with it, and we can get finished products out of it. Long-lived capital goods, consumer goods, and commercial packaging. When we break these down, they're demolished goods like autos and buildings. They can be recycled back into crude material, or they can be put back into industrial waste. The consumer goods can go into consumer waste. Okay, so back to the state and local restrictions and regulations. Industries are not required to have permits. They do not have to install landfill liners or leachate collection systems, and they don't have to monitor the water for groundwater for contamination. The amount of waste generated is actually a measure of the success of the company to run efficiently. If there's less waste that's produced per unit or volume of the product, then it's more efficient of a process from a physical standpoint. So that makes us talk about the difference between physical efficiency versus economic efficiency. And there's a difference. Okay, I'm going to leave this here. It might pop back. Oh, there we go. It popped back. What happens is when we compare it and reflect it with the economic efficiency, often it is cheaper for industry to manufacture its products or perform its services if it's quick but messy. So it can be cheaper to generate waste than to avoid generating waste. So the economic efficiency is maximized, but the physical efficiency is not. Our market system awards only economic efficiency. Industry has no financial incentive to achieve physical efficiency. So because of that, there's a frequent mismatch, and this is the major reason why the output of industrial waste is so great. There's also rising cost of industrial disposal that happens, and the government or the market makes the physically efficient use of raw materials also economically efficient, and if businesses do that, then they can gain financial incentives and reduce their wastes. So there's actually such a thing as industrial ecology. And industrial ecologists pursue their goals in several ways. Let me define it before I go on. They redesign industrial systems to reduce resources and inputs while maximizing physical and economic efficiency. The industrial systems should function like ecological systems with a little bit of waste. So what they do is they pursue goals in several ways. In one way, they examine the entire life cycle of a given product, from its origins in raw materials through its manufacture to its use and finally its disposal, and they look for ways to make the process more efficient. And this is what is known as a life cycle analysis that they do. And then the second step they do is they try to identify how waste products from one manufacturing process might be used as raw materials for another. An example of this would be the plastic beverage containers. These can be shredded and processed to make other plastic items such as benches, tables, and decks. Another thing that they can do is examine the industrial process with looking for eliminating environmentally harmful products and materials. And finally, the fourth is they would need to study the flow of materials through the industrial system to look for ways to create products that are more durable, that are recyclable and reusable. For example, if they take computers or automobiles and appliances and they easily disassemble them so more of their component parts can be reused or recycled into new machinery. Businesses are saving money while reducing wastes. That's one of the advantages. Businesses are taking advantage of insights for industrial ecology to save money on waste. American Airlines switched from hazardous to non-hazardous materials in its Chicago facility, which decreased the need to secure permits from the EPA. The company used over 50,000 reusable plastic containers to ship goods, and they reduced packaging waste by 90%. At the Dallas-Fort Worth headquarters, they recycled enough aluminum cans and white paper in 5 years to save $205,000 and recycled 3,000 broken baggage containers into lawn furniture. This program gathered suggestions from employees and brought over 700 ideas to reduced waste, and 15 of these ideas saved the company over $8 million in 1 year. Breweries in Canada and Sweden and Japan and Namibia use waste from beer brewing processes to fuel other processes. This is referred to as the Swiss Zero Emissions Research Incentives, where the foundation sponsors dozens of innovative projects worldwide to create goods or services without generating waste. So this is how this was developed. As a result, a brewer can make money from bread, mushrooms, pig, gas, and fish, as well as beer, all while producing little waste. Although most of the Swiss Zero Emissions Research Incentive or ZERI projects are not fully closed-loop systems, they do attempt to approach this idea. In doing so, they can cut down waste while increasing output and income, often generating new jobs as well. So some businesses have taken industrial ecology to heart, not a lot of businesses. The carpet and tile companies, Interface, they are the founder of Ray Anderson, or the founder is Ray Anderson, set on the road to sustainability about a decade ago, and Interface asked customers to return used tiles for recycling and for reuse as backing for new carpeting. It modified its tile design and its production methods to reduce waste. It also adapted its boilers and landfill for gas energy, and through these steps it cut waste generation by 80%. Its fossil fuel use was reduced to 45%, its water use was by 70%, and all doing this they saved $30 million per year. And they were able to raise their profits by 49%. So taking a look at this graphic, what we're seeing in A is a traditional brewery that produces only beer while generating a lot of waste that goes to animal feed. And then the breweries that's supported by the Zero Emissions Research Initiative, ZERI Foundation, that's what's in B, and they use their waste grain to make bread and to farm mushrooms, and the waste from the mushroom farming along with the brewery wastewater goes to feed pigs. And the pig's waste is digested in containers that capture natural gas, and they collect the nutrients used to nourish the algae for growing fish and fish farms. And the brewer will drive income from bread, mushrooms, pig, gas, fish, as well as the beer. Hazardous wastes, they come in different forms, liquid, solid, gas. We have them under different categories. We have ignitable, which these are ones that are likely to catch fire, so that's going to be your natural gas and your alcohol. Corrosive, these are ones that will corrode metals in storage tanks and equipment, so anything with strong acids and bases. That are reactive, that can chemically be unstable and readily able to react with other compounds, often explosively, or by producing noxious fumes. So ammonia and chlorine bleach are examples of those. And toxic and harmful are harmful to human health when they're inhaled, ingested, or touched, and these are your pesticides and your heavy metal. So these substances have characteristics that can harm human health or the environmental quality. Flammable and explosive materials can cause ecological damage and atmospheric pollution. There's fires that happen at the large tire dumps in California and Central Valley that put a lot of pollution up in the air, and toxic waste that have been dumped into rivers that have caused large fish die-offs like we've seen in the Chesapeake. All right, we're ending the screencast, and we will continue with the rest of the chapter in class.